An electric dipole with dipole moment is aligned at 30 degree with the direction of uniform electric field of magnitude. The magnitude of the torque acting. So torque is P cross Q, P cross E, and then magnitude is P is sin theta. Simple, right? Dipole moment 4 10 power minus 9. Electric field 5 10 power 4. Sin 30. Sin 30 is half. This 2, 5 to 10. 10 means 10. 10 power 4 is 10 power 5. 10 power minus 9. So this gives 10 power minus 4 Newton meter. These questions are from 2023 paper. A positively charged glass rod is brought near uncharged metal sphere, which is mounted on a insulated stand. This was insulating stand. Fine. If the glass rod is removed, so this is the glass rod, because of plus, this plus will pull electrons, conduction electrons, few conduction electrons. So other side takes positive charge, equal and opposite charge. If the glass rod is removed, the net charge on the metal sphere is 0. Why there is charge on this side? That's because of charging by induction. This negative charge, net negative charge, is equal to net positive charge. There is just separation of charge. When glass rod is removed, then again the net charge is going to be 0. In the situation shown in the diagram, magnitude Q, this is Q, is much smaller than capital Q. So this is capital Q. And R, distance, is much greater than this distance. The net force on the free charge minus Q and net torque. Look at these 4 options. They look scary, isn't it? True. In CET or NEET, if the options are very scary, then it should be a very easy problem. Trust me. This is a dipole. Direction of dipole moment is from minus Q to plus Q. And direction of electric field is opposite to the direction of dipole moment, P cap, right? So this is the electric field, because angle between these two is 180. Done. Here there is negative charge. Because of negative charge, force is opposite to the direction of field. See, minus Q, electric field, this is the direction of force. Done. Now, direction of force is along x-axis. X-axis force. This is z-axis. So these two options are wrong. We have to decide between these two. This gives electric field. Electric field due to dipole. Electric field times charge is force. Electric field times charge. Now, force and torque. Torque is R cross F. Let us use this equation, R cross F. Torque is R cross F. Okay. This is the position vector. With respect to O, point P is in this direction. So this is the direction of position vector. So this is R cap. Force, this is force. X-axis, this is y-axis, this is z-axis, y-axis, x-axis, z-axis. Correct? Now use right hand. Right hand, curvature of 4 fingers should be from first vector to second vector. See, first vector is upward, second vector is force. So let us keep it like this, first vector to second vector curvature. Then open the thumb. Thumb is into the board. Out of the board is positive z-axis. Into the board means negative z-axis. That is the direction of torque. See, negative z-axis, positive z-axis, k cap with negative sign. So this is the answer. It's a beautifully crafted problem with force, dipole moment, electric field, and then torque. Good. Just play with directions. Okay. A uniform electric field vector E exists along the horizontal direction as shown. There is electric field. The electric potential at A is VA. So potential at this is VA. Given. A small point charge is slowly taken from A to B. A to B. Along the curved path. The potential energy of the charge when it is at point B. So point B is lower potential energy. This is higher potential energy. Let me write like this. Lower potential energy, higher potential energy. So potential energy at this point is A into potential of, Q into, charge is Q, right? Q into potential at A. So this is potential energy. Let us give number. If potential energy is 20 unit, here potential energy is 18 unit because potential energy is less. What is the remaining 2? That is this. So this is the direction of displacement. Displacement is x minus 20 minus force into displacement. What is the force on charge in electric field? Q into E is force. Displacement is x. So potential energy at this point minus work done. QV. So this is how we can find out potential energy at B. Potential energy at A, this is potential energy at A. Okay. A cubical Gaussian surface has side length. Observe the diagram. Length of each side is 10 centimeter. Electric field lines are parallel to x-axis. So these electric field lines are parallel to x-axis. Magnitude of electric fields through phases ABCD, EFGH. ABCD. This is one phase. This is another phase. Observe the diagram carefully. There are 2 lines. There are 3 lines. Means field is stronger on this field, on this phase. ABCD is 6 kilo. EFGH is 9 kilo, 9,000. Then the total charge enclosed by the cube is. See, incoming electric field is less, outgoing is more. Therefore, there should be a positive charge. So these two are not. There should be a positive charge within this cube, right? Flux. So flux equal to Q by epsilon naught. Q by epsilon naught equal to flux is also electric field area vector cos 0. In this case 0 because angle between electric field. So this is the electric field. This is the electric field, right? And this phase, area of this phase is this. Angle between area vector and electric field is 0, cos 0. And what we want is charge. So net charge Q equal to epsilon naught should be on the other side. The value of epsilon naught is 8 point something, 10 power minus 12. Electric field is entering is 6 kilo. Outgoing is 9 kilo. 9 minus 6, 3 kilo. 3 kilo, 10 to the power of 3. So this is the net electric field into area. Area of each phase. Length is 10 centimeter. Area is 10 by 10, 100. 10 by 10, 100. Centimeter square to meter square, 10 to the power of minus 4. 8, 3, 24. This is in terms of 1, this is in terms of 2. When we manage 10 power, it will be 0.27 nano. Just check once, okay? Again, this is also a beautifully crafted problem. Good. Electric field at a distance r from an infinitely long uniformly charged straight conductor having linear charge density lambda is even. Another uniformly charged conductor having same linear charge density and bent into semicircle of radius r. Infinitely means length should be large compared to the distances. That's the meaning, right? Now, if this is a straight conductor and this is point P, infinitely long, electric field is E. Now the same conductor, charge conductor, is bent into semicircle. Since it is infinitely long, if it is finite, then electric fields are different. Since it is infinitely long, electric fields are almost equal. So E1 equal to E2. A body has a charge, the number of excess electrons, quantization of charge, Q equal to N into E. So Q is this 3.2 micro by charge of electron is 1.6 minus 19. This one, this 2. A point charge A and another point charge are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and electrostatic force on B due to A is F2. There are two charges. So this is 10 micro and this is 20 micro. Both are positively means there is repulsion. Force on this due to this is equal and opposite to force on this due to this. So F1 and F2 are equal and opposite, equal and opposite, equal and opposite. This is not, there is no opposite, right? So B. Action reaction pair. Similarly, in gravitation, 4 kg mass, okay? This is 4 kg and this is 6 kg. Which charge experiences greater force? No. Action reaction pair, force on this by this is F, force on this by this is again F. Magnitudes are equal and they are in opposite directions. Again, F1 equal to minus F2. Even in gravitational force, action reaction pair. Electrostatic action reaction pair. With magnet action reaction pair. A uniform electric field is acting along positive y-axis. Y-axis. So this is y-axis and this is the electric field. Fine. The electric flux through, let this be x-axis and this is z-axis. The electric flux through a rectangle of area 10 centimeter into 30 centimeter. Plane parallel to x z plane. This is zx. So this is xz plane. Okay. This is xz plane. To this plane, this is the area vector. So angle between area vector and electric field is 0 and area is product of these two. 30 centimeter, 10 centimeter, 300 centi minus 4. So it is 3 10 to the power of minus 2. They are asking flux, right? Electric flux. Electric flux is E A cos 0. Electric field is 3 10 to the power of 5. 3 10 to the power of 5. And area is 3 10 to the power of minus 2. 3 3 9. 9 is here. The total electric flux through a closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is the total electric flux through a closed spherical surface dipole. So this surface encloses a dipole, positive, negative charges separated by some distance. So net charge equal to 0, right? Net charge equal to 0, positive, negative. Therefore, flux is also equal to 0 because flux is net charge by epsilon naught. This net charge is plus q minus q. Therefore, sum of those two is 0. 0. If the surface encloses atoms, then also 0. Why? Atoms are electrically neutral. If the surface encloses molecules, molecules are also electrically neutral. Therefore, 0. Under electrostatic condition of a charged conductor, which among the following statements is true? The electric field on the surface of charged conductor is sigma by 2 epsilon naught. It is just sigma by epsilon naught. So this statement is wrong. Because of thin sheet of charge, this is the equation. But because of conductor, this is sigma by epsilon naught. The electric potential inside a charged conductor is always 0. It is not 0, it is constant. Any excess charge resides on the surface of the conductor. True. This is the conductor. Charge always resides on the outer surface. Let's check fourth. The net electric field is tangential to the surface. This is the charged conductor. The electric field is not tangential. The electric field is perpendicular. Tangential means like this. This is correct. So even this statement is wrong. Correct statement. So most of the conceptual type questions looks very easy, but you have to spend more time. That's the trap in such conceptual questions, because you have to analyze each and every statement, isn't it? It takes time.